All right, so that's 3, 2. We're going to get really into the sampling, and you can see there's good and bad to all sampling that we do. So first off here, I do have an activity in Edulastic. It's called the Who Wrote the Federalist Papers activity. So again, please go into Edulastic, get that done. It's a good introduction to this section. All right, so please pause the video, go do that, and come back. All right. So the first type of sample we're going to talk about is called a convenience sample. We all know what it means to be convenient for us, right? So choosing an individual from the population who are very easy to reach, right? And that's not always the best way to sample, right? We know in life, the easy way out is not always the best way, right? So same thing when it comes to sampling. So again, caution, convenience sampling often produces unrepresentative data, right? So be aware of that. So there's two big ideas in this section. The first big idea is this idea called bias, right? So bias is it happens in the following. So the design of a statistical study is bias. If it would consistently underestimate or overestimate the value you want to know when the study is repeated many times, right? We like to call this the true value, right? So if you repeat something many times, you will approach the true value. So the question is whatever you're doing, is your design causing you to consistently underestimate this true value or overestimate this true value? Okay. And again, it's not just bad luck in one sample, it's consistent, right? Consistently. Okay. All right, so example 1, orange a thirsty. A farmer brings a juice company many crates of oranges each week. A company inspector looks at 10 oranges from the top of each crate before deciding whether to buy all the oranges. Explain why this sampling method is biased. Is the proportion of damaged oranges in the sample likely greater than or less than the proportion of all oranges in the crate that are damaged? So the key here is this sentence right here. A company inspector looks at the 10 oranges from the top of each crate. So you have a crate filled of oranges, right? That's the population, the crate of oranges. You're looking at the sample of only 10 from the top. So why is that a problem? Well, think about it, right? The ones on the top are the last ones placed. Maybe the farmer knows this and he places the nice ones on the top because he knows how the inspector works. Or think about just the weight of your oranges, right? If you have a huge crate and you put a bunch of oranges in it, the ones on the bottom are going to get squished and probably open and crack and juice will spill out. So they'll look kind of damaged, but the ones at the top will look very pristine. So it might make the population of oranges look better than it actually is. All right, so how are we going to word this? Okay, well, we're going to call this a convenience sample. It is convenient to just look at the top, right? So it's a convenience sample. Okay, and we're going to say it is likely that the oranges on top of the crate, are in better condition than the oranges in the rest of the crate. Rest of the crate. And in parentheses, I'm going to put like explanation of this. So again, it could be farmer placement because he knows that the inspector only looks at the top ones. Or it could be damage by weight of other oranges. This is not necessary what's in the parentheses. This is just me giving a little bit extra knowledge to say to the teacher or whoever's reading this that I know what's going on. Okay, so that is explaining why this is biased. It's biased because I think the oranges on top are in better condition than the rest of the crate. So what does this mean? This means that the sample proportion, and when you think of proportion, again, that's the same thing as percentage, right? The sample proportion of damaged oranges is likely to be And now, again, they want to know, do you think that the proportion of damaged oranges in the sample will be greater than or less than the true proportion, or the proportion of all oranges? Well, in this 10 on the top, I doubt any of them are going to be damaged, right? So they'll have 0 out of 10 damaged. But I know for a fact that in this crate, there are some damaged ones. So obviously, this sample proportion of damage is going to be less than the actual, or than the true proportion. So it's likely to be less than the, and I use this word true because that is what we are trying to obtain, the true proportion of all oranges in the crate that are damaged. This means that the sample proportion of damaged oranges is likely to be less than the true proportion of all oranges in the crate that are damaged. And again, this is the idea of a sample versus the population, right? We're taking a sample and trying to make a general statement about the population. This is probably not the best way because of how you selected the oranges, right? Just looking on top is not the best way. Okay, if you're the farmer, it is, right? Because your oranges look really good. But again, that's where the bias comes in. All right, objective 2 is coming up.